So you may be wondering, what exactly are we doing here on this bridge in the middle of the winter in Germany? It turns out that it's a good idea to do some systems testing on a small scale before you go and do a big giant test, like throwing a nose cone out of an airplane to make sure your parachute systems work. So today we're here to verify a couple of things. First of all, that our wound nose cone that we have is actually strong enough to withstand the impact into the water. Second of all, to make sure that the avionics package, this little box that we've created, is going to be waterproof once we throw it into the water. This is going to be what keeps our electronics dry and make sure that we're able to recover our data for the test, but also for the rocket. So what did we do in order to make this avionics bay waterproof? As you can see here, it looks like we just 3D printed this bay out of PLA. But as you might know, PLA isn't exactly waterproof. So we had to do a little bit of engineering in order to make this able to withstand the water impact. First, we basically painted a layer of epoxy around the outside and also on the inside. In addition to this, we're using a special sealing method where we have a seal groove on the top lid, and that is going to be compressed against the body of the bay, and essentially that should form a waterproof seal. But unfortunately, this didn't quite go the way we were expecting. As you can see, the nose cone went into the water quite well, which is good for the structural integrity, but this is only part of the test. We also had to go back home and open it up to check to see if there might be any water inside. And this would tell us if the whole thing was waterproof or not.
Have a little bit of water sitting on the bottom.
Why did we have water in our avionics bay? Well, it turns out that we have some wires that need to go through the lid, and these wires, of course, create a spot where there could be leakage. We bought these fancy seal glands that we use in order to seal the wires when they're passed through them, but unfortunately, these glands don't exactly account for multiple wires going through them. And there's these little tiny spaces that occur between the wires when you stack them all together, because you can't have them make a completely waterproof seal, so to say. So basically we need to plug that gap to make sure the water doesn't have a leak path that it can go through in order to fill up our avionics bay. So our strategy for dealing with this is to do exactly that. We're just going to use some hot glue to fill all of those little gaps to make sure that we don't have any water leaking through those seal glands. But the drop test off of the bridge in Bremen wasn't the only systems test that we performed before we were ready to go throw this nose cone out of an airplane. We also did many systems tests on the electronics to make sure that they were triggering all the mechanisms properly for the recovery system. We also did some drogue deployment testing where we would send an artificial trigger signal to the drogue deployment mechanism and see if it was able to deploy our parachute properly. Finally, we also did a lot of destructive shock testing on our parachute bay as well. We had to go through 6 iterations of this to finally find a solution that would actually be able to survive the shock loads of a parachute deployment. So after all this, hopefully we're ready to finally throw this thing out of an airplane and have it land successfully. But before we can carry out a drop test campaign like the one we want to do, there are a couple of hurdles that are actually in our way. First of all, we have to actually be able to get regulatory approval in order to drop something from 600 meters. After all, some people might take offense to a nose cone just landing on their house somewhere. In addition to this, we also need to find a space where we can do it safely. So we need a clear space that is, a couple hundred meters across that we can land a nose cone in and there won't be any damage. And finally, we need a pilot who's crazy enough to fly all the way up to 600 meters and throw the nose cone out the window of his plane. Lucky for us, all these problems were solved with a cooperation with a company called Klaus Space Transportation. The CEO of Klaus Space Transportation turns out to be a plane pilot, so he was quite happy to fly our nose cone up and perform this drop testing. In addition to this, Klaus Space Transportation is quite experienced with doing drop testing because they're actually developing some technology whereby they're going to try to return vehicles and payloads from orbit.
My name is Sebastian Klaus. I'm the founder and CEO of Klaus Space Transportation, and our vision is to make space transportation sustainable. We built inflatable atmospheric decelerators, so it's a kind of high-velocity parachute to recycle and reuse rockets.
So all in all, it was kind of a perfect marriage. There's just one catch. It turns out that the place that we can do this is 8 hours away.
Brandstraße.
Yes,
You have the white flag and the green flag.
White flag, green flag, I have the rope.
Da da da.
After an exciting drive through Germany, we finally arrived in Baden-Baden. But it turns out that when we tried to start doing some final testing, that things weren't quite working the way we wanted it to. The reliability of our parachute trigger signals was not exactly stellar. Sometimes the parachutes would deploy, but sometimes nothing would happen.
3, 2, 1.
1, 2, 3, 4, 5. We should be throwing it out. 6, 7, 8, 9, 10. Drogue. Drogue. 1, 2, 3,
No, that was
4,
also the main.
5. Our main also deployed.
Yeah.
And we once again crashed the lake at 28 meters per second. Finally, after a restless night of correction and error testing, we were finally able to iron out all of the issues and be confident for drop testing the next day.
3:28 a.m.
9, 10, drogue. 1, 2, 3, 4, 5, 6.
Good enough?
I think we landed. Thankfully. The next morning, we had an early start at 6 a.m. And the reason for this is that we wanted to take advantage of all of the light that we had to do the drop test. After all, we want to be able to actually see the thing that drops out of the plane to make sure that everything's working properly. And as you might imagine, there's a lot of preparation that goes into making sure that everything's ready to be able to perform a task such as this. After we loaded up everything into the car, we headed over to KST headquarters in order to have a safety conversation to make sure that everything for the day was planned out and going to happen in a safe way. After a couple cups of coffee and our safety talk, we were ready to head over to the hangar to set up in order to perform this drop test. Alright, so we have set up our nose cone for the first drop. We basically, this is not the one, but this is the one for the second drop, but just to explain to you, we have our recovery bay and our avionics package. We had to open it up to put in the battery connection to make sure that's powered on. And we have a little switch that when you push it in, turns on the whole system. So we put that in, and that caused our green LED to go on, which means that the system is passive and ready to operate. We have a pull pin on the bottom. If you see this one down here, we have an identical one on the one we're flying. And basically when this gets pulled, that's going to arm the system, and that indicates that there's 10 seconds until the drogue parachute goes. So the idea here is that you'll pull the pin 5 seconds before you push it out of the plane. So you pull the pin, 1, 2, 3, 4, 5. We push it out, and that gives 5 more seconds of free fall, and then the drogue chute will deploy. There's also a line of code in there that will try to detect free fall. So if it's a little bit off based on when you push it out, after free fall is detected, it's 5 seconds. So for now, it's all packed into the nose cone and it's mounted. The way we've done that is we have basically 4 screws that are on the outside that we have to screw in on the bottom and on the top. And that's the final product. I don't think there's anything more to say about it. It's ready to fly. Hopefully it'll work. And here we split up into 2 crews, the air crew and the ground crew. The air crew would be responsible for doing everything on the plane. Taking the nose cone, flying it up to 600 meters, and performing the drop. The ground crew would be responsible for actually recovering the nose cone, and also for the operations in terms of whether it was safe to drop or not. But unfortunately, when the ground crew got to the drop site, it looked like the German weather wasn't quite cooperating with us.
Alright, so we've just arrived about half an hour to an hour ago to set up the ground station. The things we had to do were first to get the boat set up so that we can do the recovery on the water. So we've it's kind of a boat half together, so we have the boat and we have the motor and we had to put everything together, so that's all done. We also had to set up the cameras so that we can see the drop. But if you can see right now, it's quite foggy. So we can't really see much on the lake. And that kind of has to be solved before we can actually do the drop. So we're going to wait a little bit for the fog to clear so that we can actually see those things happen.
But unfortunately, it looks like the weather didn't get any better, and we weren't able to do a drop test that day. One of the reasons this happens is because the lake that we're dropping this Nosecone into is actually right beside the River Rhine, and in the winter, it's notorious for producing a lot of fog in the morning in this area. Another one of the reasons why you probably shouldn't be doing drop testing in the winter.
Obviously.
But hey, we had to cooperate with the German weather. So with that devastating news of the German weather canceling our plans to do this drop test, we were a little bit down in our spirits. I mean, we'd come all this way, all the way to Baden-Baden, driven 8 hours, spent countless hours building this system, and it looks like it might not happen. We decided to drown our sorrows that night and watch a little bit of the World Cup finals.
Come on!
But there was still a little bit of a glimmer of hope on the horizon. There was a little bit of good weather that looked like it might appear in the early morning the next day. There were 3 criteria we basically had to fulfill. Number 1, we had to have enough visibility to be able to actually see the payload as it dropped. Secondly, we had to make sure that the winds were below 5 meters per second at the level that the plane was flying at, which is actually pretty slow. And we had one more constraint, which is that the plane that we had booked was actually only booked until 12 o'clock the next day. So after that, it was someone else's plane. That gave us basically 3 hours from 9 a.m. until 12 in which this drop test could still occur. Everything depended on the weather being good the next day and everything working out properly in order for us to perform this test, maybe. But lucky for us, the next morning when we woke up, we saw that the fog had kind of cleared and everything was kind of looking good. So we drove off to the KST headquarters and then to the hangar with optimism in our hearts. The assembly process in the hangar went a lot faster this time because, of course, we had done it the day before. So this also boosted our spirits a little bit more. And finally, at around 9:30, we were ready to go to do this drop test.
just had our drop test. The Nosecone landed roughly in the lake where we were expecting, just a little bit to the north. We had a proper drogue parachute deployment, and then we had a proper main parachute deployment, but unfortunately the main chute didn't inflate. We were going to take the whole thing back to our base, and we're going to kind of look into it and see why exactly the main parachute didn't inflate. But we suspect it's probably something to do with some of the lines or something. We're not sure yet. We went out on the boat, retrieved it, everything went well with that, so now it's just back to the base to open it up and get some data out of it.
So overall, our drop test went relatively well. Just to go over some of the main topics of what we were looking for, first of all, the drogue deployed perfectly. The box came right out of the center of the deployment mechanism, just as we expected, and the spring deployment mechanism worked very well as well. The drogue parachute inflated just as we expected, and worked very well to slow down the payload to the velocity that we wanted. The next step didn't go so well though. The main parachute did come out, but it didn't actually deploy to its full diameter. The reason for this is that when it came out first, it kind of wrapped itself around the drogue line, which caused it to get a little bit tangled and not be able to open up fully. However, this can be stopped easily by just making sure that the main doesn't come out too early, like it did in this case, and that will stop it from wrapping around the drogue line like we saw. Finally, the structure of the nose cone worked very well. It was able to actually withstand a landing force much higher than we were even expecting. So excellent performance there for the structure of the nose cone. Finally, the integrity of the avionics bay was not exactly 100%. We did see a little bit of water inside of the avionics bay when we opened it up. This didn't cause any major damage, but had it been there for a lot longer, like maybe if it was in the ocean after a Transcendence launch, it may have filled up so much that it may have caused the nose cone to start sinking.
Well done!
But overall, the mission was a resounding success. We were able to prove a lot of our main objectives and also prove the technology that we're using in order to perform this recovery. We have a couple things that we want to change about this nose cone for the next iteration. So we're looking forward to being able to drop this in the future and finally see it fly on a rocket. Be sure to stay tuned with us in order to see how this system evolves and hopefully finally see it fly on a rocket. And remember to keep expanding your horizons.